Okay, I believe yesterday I already started the discussion about couple, right? And when we talk about couple, we are talking about two forces which has the same magnitude, but the direction is completely the opposite. Okay, so as you can see, this is some example of a couple. With my stylus. Wait a minute. Sorry. I don't know. I just saw my stylus got stuck. Okay. So I want to re-explain what is couple because it's part of the it is very important for you guys. Okay. So basically, if you have two forces, right? If you have two forces, but both has exactly the same magnitude. For example, the first force F1, for example, is 10 Newton, and the second force F2 is the same, 10 Newton as well. The magnitude are the same, but the direction are completely the opposite. Okay, this kind of a force combination, we call it as couple. Okay, we call it as couple. And what is so special about couple? Yesterday, we already talked about it at the end of the class. Anyone still remember what is so special about couple? Irsyad Nabil.
Hello, sir.
Hello, Irsyad. Do you still remember what is special about couple?
The moment of force is like always, what's the name?
The moment due
Mutter.
to both, yeah.
Oh yeah,
The
due
moment,
to both.
yeah, the moment due to both forces is always the same at all center of rotation. So for example, if we have for example, we have this particular body, right? Okay, and we have couple 10 Newton, F1 and F2. Okay, so the moment which is caused by both forces at this particular point O1 or at this particular point O2 or at this particular point O3 will be what, Nabil?
Always the same.
Always
10.
the same. Yeah, always the same. And the rotation as well, the direction of the moment will be the same as well. So that is so what there is a what is special about couple. Okay, so when we talk about couple, we can think that if a couple walks on a particular body, for example, like this, right? There is a one body where a couple walks on it. Okay, we can think that there is a moment which is happening at that body, and the moment which is caused by that couple will be the same as F multiplied by D, like that, where D is the perpendicular distance between both couple. Perpendicular distance, remember, okay? Perpendicular distance between both couple. So if D here is equal to 2 meters, okay? If D here is equal to 2 meters, okay? what is the couple? What is the moment value which is caused by F1 and F2 at this particular body? Nabil, still Nabil.
It's Irshad, sir. Nabil is somebody else here.
Okay, then Irshad.
By which force?
By both forces, 10 Newton.
Oh, by force. Okay. F1 would be 0 because there is no distance. F2
No,
would
I mean,
be 20.
Yeah, the question is not like that. So
Oh,
just now I told you, right? When we talk about a couple will cause a moment, and the moment that is caused by a couple, okay, it will be the same in the whole body, right? Now my question is, what is the moment which is caused by both forces, okay, when the magnitude of the force is 10 Newton each, and the perpendicular distance is 2 meters?
20?
Yes, correct. Just directly use that
okay.
one. Okay. Moment is equal to F multiplied by D. Then in this case is 10 Newton multiplied by 2 meters. So 20 Newton meter. Okay, Irshad?
Yes, thank you, sir.
And it will be the same in the whole body. So if the center of rotation is here, the value of the moment will be 20 Newton meters. If the center of rotation is here, it will be the same as well, 20 Newton meters. If it's here, the same as well. So the whole body, the moment which is caused by both forces in the whole body will be exactly the same. Okay, do you get it, Irshad?
Yes, sir.
Okay, good. Anyone still having a problem with couple? Because why I try to repeat this, repeat the explanation on couple, because this is still quite new for you guys. Okay. Mungkin saya coba ulangi lagi pembahasannya dalam bahasa Indonesia ya. Jadi saat ada couple itu adalah gaya dengan besar yang sama persis, tetapi arahnya berlawanan. Saat ada couple di suatu benda, oke, di semua titik di benda tersebut, dimanapun itu, akan terjadi momen dengan besar yang sama persis, dan besarnya itu sama dengan F magnitude dari gayanya dikalikan dengan D. D itu adalah jarak tegak lurus antara kedua gaya tersebut. Seperti itu, ya. Jadi mau dimanapun itu center of rotation-nya, pusat perputarannya, besar momen akibat couple, oke, mau di O, O1, O2, O3, O4 seperti itu, besar momen akibat couple itu akan sama. F dikalikan dengan D, seperti itu. Till this point, anyone want to ask question? Hugo, do you understand about this, Hugo?
Hello, sir.
Yep. Do you understand?
Still processing.
Still processing, which means that some part of it you still don't understand. Which part that you don't understand, Hugo?
So we just multiply with the perpendicular distance and force, correct, sir?
Yes, correct. The magnitude of the force multiplied by the perpendicular distance. Remember, the magnitude of the force here is the 10 Newton. So you don't have to sum both. Okay, you don't have to sum both. Just use one of the magnitude, multiply by the perpendicular distance, and that will be the moment which is caused by couple.
Oh, okay.
Yeah, and it will be the same at any point in that body. Do you understand what does it mean, right, Hugo? So,
yeah, so
when we talk about moment, we normally talk about center of rotation, right? Remember, like this moment which is caused by certain force at one center of rotation, like that. The same as this one, the center of rotation is here. What is the moment due to 600 Newton? But here, when we talk about couple, wherever the center of rotation is, the value of the moment will be the same. The magnitude of the moment will be the same. The direction will be the same as well. Do you get it, Hugo?
Okay, sir. Okay. Yeah. Thank you, sir.
Okay, no problem. Anyone else still a bit confused about this? Marsa, Virginia. Hello, Marsa. Yep. Can you catch up, Marsa? Yep, yep.
Yeah, I can, sir.
Okay, good. How about Sakya? Do you understand, Sakya?
Yes, sir.
Okay, good. Okay, please remember if you are having a difficulty in catching up with me, please ask me directly. You can, for international students, ask me in English, but for regular students, you can ask me in English or in Bahasa. Okay. Now, talking about couple, because it's very important, let's try to do some practice. Okay. This is the first problem that we want to try to solve. Okay. This is a boat. There is a boat. Okay, big boat. The big boat. This one. Okay. In order, the boat has two propellers. Okay, two propellers. Okay, the propellers by the captain of the boat. Okay, the captain of the boat run both propellers on the opposite direction. Okay, so one propeller will give thrust like this, and the other propeller will give thrust like this. Okay, and the thrust, okay, and the magnitude of the thrust F there is equal to 300 kilonewton each. Okay, 300 kilonewton each. But remember, the direction is the opposite to each other. Okay, and now the question is, there are two tugboats. Okay, this one and this one. Okay, we have two tugboats. Okay, and both tugboats, okay, give forces to the main boat. Okay, pushing forces to the main boat. And the question is, what force each tugboat need to exert in order to make the main boat to remain stationary? Oke, saya coba jelaskan dalam bahasa Indonesia. Jadi dalam kasus ini ada satu boat besar, satu kapal besar. Kapal besar itu si kaptennya membuat propellernya, si baling-baling kapal di bawah airnya itu ya, di dalam airnya itu untuk bekerja berlawanan arah. Oke, salah satu baling-baling itu memberikan thrust gaya dorong sebesar 300 kN arah ke belakang. Dan juga yang satunya lagi memberikan gaya dorong 300 kN tetapi arahnya ke depan. Seperti itu. Nah, yang ditanyakan di sini, di saat yang bersamaan itu ada boot kecil pendorong yang biasanya digunakan untuk manuver kapal, ya, membantu manuver kapal. Nah, si boot kecilnya itu memberikan gaya dorong kepada kapal utama. Nah, yang ditanyakan adalah besar gaya dorong dari masing-masing boot kecil itu harus berapa supaya kapal besarnya ini tetap dalam kondisi diam seperti itu. Oke. Anyone here want to help me to solve this one? Anyone? Satria Madani. Halo Satria.
Hello, sir.
Would you mind to help me to solve this one, Satria?
Yes. Hello?
Hmm.
Yes, sir.
Mhm. So what we supposed to do, Satria?
Wait, let me read the question first.
I believe I explained it quite clearly just now. Do you get the question, Satria?
Yeah, I'm still trying to comprehending it.
So basically,
Yep.
the boat has two propellers, okay, and both
Okay.
propellers giving forces, giving thrust forces, giving thrusts, and both thrusts is in the opposite direction, but the magnitude are the same, 300 kilonewton. Okay, the distance between both forces is 12 meters. Okay.
Okay.
And the question is, if there is a tugboat which giving a pushing force to the main boat, okay, what is the pushing force that each tugboat need to exert to the main boat in order to make the main boat stationary?
Okay. I think we can use the MP equals MF, sir.
Sorry, MP, what is it? MP?
The push and then
Mhm.
equals the force.
Oh, sorry. Can you repeat again? Hello, sorry.
The is the push the first the boat.
Mhm.
Yeah. Hello.
Yeah.
Mm-hmm.
I believe
So
the one that has
we need to find the
let me turn off my camera. Yeah. You need to find what?
push force from the boat, like
Yes, correct.
the small boats, right?
Yep.
Okay. So we have to find the moment reduced by the P couples.
This one
Equals
first or what? You want to find the moment due to both forces first?
both forces. Yeah.
Yes. Okay.
And
So
then
what is the moment which is caused by both forces?
it will be into the perpendicular of the
Mhm.
so we subtracts 120 by 50.
Oh, you want to find the this one first. Okay. So
Yeah.
basically, this one will give force like this one will give force like this. So you want to find the perpendicular distance first, okay?
Yeah.
Okay, so this is the perpendicular distance. What is the perpendicular distance there?
It would be 70.
70. 120 minus 50, right?
Yep.
70 meters. And then if
And
we
then
assume
equal,
that this value is P, okay,
mhm.
then
And then will equal the moment of the perpendicular F.
okay. And
Yes,
then we
so
will be able to find P, right?
we will, yeah,
Okay,
we'll be
yes,
able to find the P.
that's correct. So basically, okay, thank you, Satria. So basically, in order to solve this, okay, the total moment which is supposed to work on the boat, it's supposed to be equal to 0, the total moment, okay? There are two moments working there, okay? The first moment is happening because of the F couple, okay? This is the first moment, okay? Satria, that particular moment, the direction of that
Yes.
particular moment due to the force F is clockwise or counterclockwise?
I think it's clockwise.
Clockwise, correct. Is you don't have to think that long, okay? Because it's going like that on the top and going like this on the bottom, right? So the rotation will be like this, right? It's clockwise, correct, right, Satya?
Yes.
So the first moment, the value will be, what is the value of the first moment?
It will be
300, right?
yeah,
300
be
kilonewton multiplied by
12.
12 meters.
Yep.
Right. And the direction will be clockwise. Okay. What is the, okay, this one is supposed to be 3,600, right? Kilonewton meter clockwise. Okay. So in order for the total moment to become zero, okay, then the total moment supposed to be m1 plus m2, right? M2 is the moment due to P here. Okay.
Okay.
So M2, what is the magnitude of the M2?
It's P times 70.
P times 70, yes, correct. And the magnitude is supposed to be equal to what?
Counterclockwise.
No, the magnitude.
The magnitude.
In order for this to become zero. So I will write it again. Okay. We know the value
So-
of M1, right?
Equals to
Supposed to be equal, right? But with the opposite direction, if this one is clockwise, in order for it to nullify it, you're supposed to
the other
have
one.
counterclockwise, right?
Yep.
So M2 is supposed to be 3,600 kilonewton meter, but counterclockwise. And the value is supposed to be the same as P multiplied by 70 meters,
70.
right?
Yep.
Yeah, in this case, you can see, right, if the tugboat give pushing force there, the rotation, the moment due to both P forces will be counterclockwise, right?
Mm.
Correct or not, Satria?
So, pardon?
So if the tugboat, both
Yeah.
tugboat give pushing force like this,
Mhm.
so the moment due to couple P there, it will be counterclockwise, right?
Yep.
So it will nullify
It
the
will nullify
M1.
the other one. Yeah.
Yes. So now what we need to find is just the value of P. Then P will be equal to 3,600 divided by 70, right?
Yep. So I got 51. Oh, sorry.
51.
51.42.
51.42. Okay. Kilonewton. So that's the value, that's the thrust that's supposed to be exerted by the tugboat in order to make the main boat to stay stationary. Okay, thank you, Satria. Yeah.
Okay, thank you, sir.
Anyone here still having a problem with this? If you are finding any difficulties on this, please let me know. Lilo, do you understand what is Lilo?
Yes, sir.
Good. Okay, William. Yep.
Sir. Excuse me.
Yeah, Reinhard.
Center of the rotation. Does it affect where does the rotation occurs?
Sorry, can you say that?
Does it
Okay.
affect any of the calculations and the drawings if there are a certain center of rotation that we must to obtain first?
No, not necessarily, because we are here talking about couple, William, right? When we talk about moment, the normal moment, okay, yes, it will affect the calculation. The center of rotation will affect the calculation. Okay, but when we talk about couple, remember when we talk about couple, okay, I clearly said before that a couple will create exactly the same moment value at each point of the body. So in this case, we have one couple here. Okay, wherever the center of rotation is, the moment which is caused by this particular couple will be the same. And the second couple as well, wherever the center of rotation is, the moment which is caused by this particular couple will be the same. Do you get it, William?
Yes, thank you, sir.
I believe just now Reinhard want to say something.
Yes, sir. I just want to ask about the positive or negative sign for the clockwise or the counterclockwise is the negative one.
Okay, it's up to you. The answer, the correct answer is up to you. So like this. Oh yeah, I forgot. I supposed to define from the beginning that clockwise is positive. Because clockwise is positive, that's why M1 here has positive value. M2 has negative value because this one is counterclockwise. Okay, Reinhard?
Okay, sir.
So basically, you can use whatever you like, okay, as long as you define it from the beginning. So as long as you define in the beginning, right? For example, this one, I define it. I supposed to, but I forgot. But now I tell you guys, we supposed to define it in the beginning. Okay, clockwise is positive. If clockwise is positive, this calculation is like this. The calculation is supposed to be like that. But if some of you ask me, is it possible for us to use counterclockwise as positive value? Yes, you can. Okay, you can do it as well. If the counterclockwise is the positive value, okay, counterclockwise positive, then the value of M1 here will be negative because it's clockwise, right? So it's negative. But the value of the magnitude of the not magnitude, the value of the M2 will be positive because it's counterclockwise. The calculation will be still the same. The total moment will be 0. And P will still be 51.42 kilonewton. You get it, right? Am I make my sorry? Is it clear, Reinhard? Hello, hello.
Yes, sir.
Okay, good. Okay, I think I will continue. Anyone else want to ask question? Not? Okay. In that case, I will continue then. Okay, now we are talking about human hand. Okay, we are talking about human hand here. Okay, if you are confused about the units, then you don't have to think of it as a pound and inches. We can just replace it by this one is centimeters. Okay, sorry. Newton. Okay, this one is in Newton. Okay, and the distance is in centimeters. Okay, for you guys, in order to for you to in order to make it clearer, okay, for you guys, okay, because most of the time we will not use the pound system, okay. Most of the time we will use the SI system, okay, SI system. Okay, for this particular problem, I think I will ask some of you to help me. Raka Wicaksono.
Yes, sir.
Oke, Raka, apakah kamu paham dengan permasalahannya?
Lagi proses pertanyaannya, Pak.
Oke, sip. Silakan coba dibaca. Okay. At the same time, I will try to explain the problem. Okay, so basically, this is what is happening on your hand when you try to raise certain mass like that. Okay, A there is a mass that you want to lift like that. Okay, and the weight there is 8 Newton. We use Newton, okay? In order to make it easier, we use Newton. And then at the same time, your forearm has a certain weight as well. And the weight of your forearm is 5 Newton. The center of gravity of your forearm is here. Okay? The question is, what forces that the bicep muscle need to exert in order for your hand to be able to raise this particular mass. Okay, so your bicep muscle is positioned here. So we have to calculate the magnitude of the force which need to be produced by the bicep muscle in order for your hand to be able to lift that particular mass. Oke, apakah dipahami pertanyaannya tadi, Raka?
Iya sudah, Pak, saya bisa dipahami.
Sip. Menurut kamu cara penyelesaiannya bagaimana, Raka?
Sebelumnya mau tanya, Pak. Jadi pusat momennya itu di O ya, Pak?
Betul sekali. Pusat momennya di O. Karena pusat perputarannya kan di O. So the center of the moment and the center of the rotation will be at O. Why is like that? Because that's your elbow. Karena itu sikut kamu kan. Jadi pusat perputarannya di situ. Kebayangkan ya, pusat perputarannya di situ. The center of rotation is there, and your bicep muscle is here. Okay, there is your bicep muscle, and the center of gravity for the forearm is here, and the center of gravity of the mass is here. Okay. Penjelasannya bagaimana, Raka?
Kalau menurut saya, Pak, di penjumlahan antara gaya dikali jarak di A sama G akan sama dengan perkalian gaya dengan jarak di T, Pak.
Okay, yep. Okay, so So basically what Raka said is correct. So at least the force that it need to be produced by the muscle, at least, right, supposed to follow this sigma moment equal to 0. The total moment is supposed to be equal to 0. The total moment at O, okay, at center of rotation O should be equal to 0. Okay, so in this case, okay, the whole moment will caused by the total moment, which is happening at point O, it will be the summation of the moment, which is caused by mass A. Okay, so that one is supposed to be 8 Newton multiplied by the perpendicular distance. Jarak tegak lurusnya dari gaya 8 Newton ke titik O berapa? Berapa?
13 cm.
13 cm, tuh. Kemudian setelah itu kita tambahkan ya dengan apa lagi itu? Misalkan kita asumsikan dulu ya, clockwise positif. Jadi 18 Newton kali 13 cm itu positif ya, itu karena dia clockwise terhadap titik O. Oke. Why I say that 8 Newton multiplied by 13 centimeters is clockwise, because the center of rotation is at point O and the force is going downwards here. So when we talk about it, the center of rotation at point O and the force is going downwards, so the moment which is caused by the 8 Newton will be counterclockwise. And I already defined from the beginning that counterclockwise is positive. So it's positive. Okay. Next, what else that we have? Raka? Momen selanjutnya yang bekerja, di mana? Di G ya?
Di G.
Ya, di G. Besar gayanya berapa? At G, what is the magnitude of the force? Supposed to be 5, right?
Yes.
5 Newton. And what is the perpendicular distance? Halo Raka, jarak tegak lurusnya berapa Raka?
Seperti harus dicari dulu ya Pak.
Yep, betul sekali. You need to find it out, but it's quite simple because it's 6. You have 6 centimeters there, and you have 55 degrees there, right? 55 degrees is the angle here. So if you want to find out the perpendicular distance using those two, what is the perpendicular distance? Jadi ini ada 6 cm, ada 55 derajat Raka. Ya. 6 cm itu kan yang panjang miring ya. Kalau kita ingin cari tahu panjang horizontalnya bagaimana?
Berarti 6 dikali sin 55 ya.
Betul sekali. Oke. 6 cm multiplied by sin 55 degrees. Okay. So we calculated already the moment due to at point at point O due to A, at point O due to 5 Newton at G. The last one is supposed to be the moment due to the muscle, right? Momen gara-gara muscle-nya gimana? Raka?
Minus.
Karena, okay. So the moment due to the muscle, it's supposed to be counterclockwise, right? Because it's going upwards, okay? And if the center of rotation is at O, the rotation will be like this, counterclockwise. And remember, we defined that clockwise is positive from the beginning. That's why the moment due to the muscle will be negative. Oke, negatif. Negatif apa? Negatif apa kali apa?
Dikali 2 cm, Pak.
dikali 2 cm. Karena itu sudah jarak tegak lurus ya. Nah, secara total ini akan sama dengan 0 karena ini semua momennya sama dengan 0. Seperti itu kan. In total, the total will be 0. Okay, because we want to find out the least tension force that need to be exerted. Okay. Using this equation, can we find the value of T? Pakai persamaan ini apakah kita bisa mendapatkan nilai T? Raka?
Bisa, Pak.
Bisa ya. Oke. Jadi 8 kali 13 itu berapa tuh? 80, 20.
104, Pak.
Yes. 4 Newton centimeter ditambah 5 Newton tambah 5 Newton kali 6 cm kali sin 55 berapa itu?
Sekitar 24,57, Pak.
Newton centimeter. Okay. And the total, and it will be the same as T multiplied by 2. I move T multiplied by 2 to the other side. Okay. So in this case, the value of T will be 104 plus 24 0.57 divided by 2. Oke, jumlahnya berapa itu? 128,57 begitu. Ini 2 cm ya. Nilainya jadi berapa? 64 ya.
64,285, Pak.
Newton. So this is it. Oke, terima kasih Raka ya. Oke, so this is the least amount of forces that needs to be exerted by the bicep force. Okay, the least. But the question here is, what must the bicep tension force be so that the overall moment about O is 0? So it's correct already. So the answer will be 64.285 Newton. So the question is not to lift the mass, but just in order to make it in stationary position. So the total moment at O is equal to 0. Okay, the total moment at O equal to 0. So the value of T there is supposed to be 64.285 Newton. For this particular problem, anyone want to ask questions? Nabil FR. You understand?
So far, understand.
Yep. Okay, good.
So can I ask?
Yes, of course.
For the ball in point A, there's a difference in perpendicular distance, but there's also a difference in like in the height. I mean, so we don't need to count that.
Oh, no, you don't have to, because you can see, right? The force line of action is completely vertical. So in order to for us to find the perpendicular distance, this is our perpendicular distance, right? The horizontal distance is actually the perpendicular distance. Do you get it?
Okay.
Yeah.
Thank you.
On the other hand, the force 5 Newton there, okay, it's vertical as well. Okay, so this is the force line of action. So the perpendicular distance is supposed to be like this, right? But unfortunately for us, the distance that we have from O, okay, the distance that we have from O to G is this distance. That's why we need to do a simple calculation there. Okay, 6 centimeters multiplied by sin 55 degrees in order to find the horizontal distance here. That's our perpendicular distance. Do you get it? Hello? Who asked that question just now? Okay, anyway. Anyone else want to ask a question before we close the class? So later after this, yep, Marsha.
Sir, so for the T, I was a bit confused at first. So the T is actually for the whole arm, sir. It's like so for the first in T, it's like supporting the whole arm.
Oh yes, correct. It's supporting the whole arm. Actually, basically the T there, okay, the T there is actually okay, the T there is actually happening at the this particular part of the bone. Okay, so when we talk about muscle, muscle is actually glued to the bone, and it can pull the bone here. And this is the T there is actually the pulling force from the muscle to the bone. Do you get it, Marsha? So basically, yeah. So basically, that T is actually holding the whole masses there, holding the whole moment there, due to the 5 Newton and due to the 8 Newton as well. Okay, Marsha?
Yes, sir. Understand. Thank you, sir.
Yeah, no problem. Okay. Anyone else want to ask a question? Oh yeah, one more thing. Starting from next week, most likely, because if I'm not mistaken, our Thursday, there will be a holiday on our Thursday. I forget when it will be, but in order to accommodate for that, okay, starting from next week, but I will not use it on. I will not use it the whole time. I will not use it in the whole semesters, but in some of the week, I will use 2 hours on Friday. And next week, the class next week, so on Friday, the class will be from 7 in the morning till 9 in the morning. Okay, in order to accommodate for the holiday on Thursday. Okay, I think that's all for today. Okay, thank you very much for listening. Okay, for those who haven't taken the who haven't put the attendance yet, please check your academic.itb.ac.id and mark your attendance there. Okay.
Sir, I
thank you
think
very
the
much.
holiday is on Tuesday.
Tuesday or Thursday? There is one holiday on Thursday. Not
I don't know.
Not the Chinese New Year, but I believe in 1 month there will be a holiday on Thursday. Okay. I think that's all for today. Okay. Thank you very much for coming and listening. See you guys on Thursday next week. Oh yeah, one more thing. I will put one homework in the MS Team and the A2Next. Okay. Today, maybe tonight. Okay. Please check for it. Okay. Thank you very much, guys. See you guys next Thursday. Bye.
Thank you, sir. Have a good day.
Thank you very much,
sir. Sir, have a good day.
Have a good day as well.
Thank you, sir.
Sir.